So here we can see the illustration 1, compounding. So what is happening if $100 was invested in an account? Let's say this is an account, and in this account you are depositing $100. And this particular account, let's say bank account or whatever investment account, is giving you 10% compound interest. Okay, how much would be in the account after 4 years? That means they're asking how much this 100 will become after 4 years. So the final answer can be something which I'll calculate and directly tell you the answer. Okay, instead of all this explanation, you can take 100. This is the present value into 1 plus r, that is 1 plus 0.10 whole power 4 whole power n. Can you just calculate and tell me what's the answer, Hamsika? Then I'll tell you what are they doing here. Okay, fine, fast. Tell me the answer.
So 384.16.
Sorry?
384.16.
384. You just do this 1 plus 0.10, 100 into 1.10 whole power 4. Can you do this 1.10 whole power 4? How much this is? I don't think the answer is right.
So 1.4641 into 100.
How much?
146.41.
146.41. 42, correct? 1.10 into 1.10. Just a second. Yeah, 1.46. Okay, fine. 146.41 or 42 is the answer. Okay. So this is we got directly. But what about this? This 100 on 100 you're going to get interest of $10 in the first year, $11 second year. Why? Because 100 plus 10 will be 110. So first this interest and principal, if you add, you'll get amount. Amount is 110. This amount will become the principal for the next year. So on that again interest. Okay. Then 110 plus 11, 121 into 10% is 12 somewhere around. Okay. So again this 110 plus 11 is the amount. This has become the principal for the next year. That is second year end and third year beginning. Okay. So we got the interest again. Again 121 10% will be somewhere around 12 point something. Okay. So 133 of this 10% will be 13. Okay. So again 110 plus this here 121, 133. Okay. And then interest. Are you understanding, Hamsika?
Yes, sir.
Are you sure? Yes.
Yes, sir. Yes.
Yeah. So they have done this here also. So first years is this, second years is whatever you have in the first year. Okay. First year's amount plus that much you have to take as interest. But instead of going for all this lengthy and like complicated calculation, it is better if you directly do the answer. Okay. But if they ask you what is the amount at the end of the first year, so you have to take 100 into 1 plus 0.10. This is first year amount. If they ask you the amount at the end of second year, so 100 into 1 plus 0.10 whole square, because this is year 2. If they ask you at the third year, 100 into 1 plus 0.10 whole cube, that is they are multiplying here twice, you see, square. Here they are multiplying thrice, you see, cube. Then again, if it is fourth year, 100 into 1 plus 0.10 whole power 4, they're multiplying 4 times, so whole power 4. So at the end you'll get the answer. Okay, shall we move forward?
Yes, sir.
Annual compounding. Annual compounding is nothing but you will be compounding for the entire year. If it is semi-annual compounding, you'll be compounding for half the year. Okay. So we invest $500 in a building society account, earning compound interest of 10%. How much will the investment be worth in 5 years time? Can you tell me the answer for this, Hamsika? I'm waiting. Come on.
Sir, 805.255.
Sorry.
805.255.
Let's see. 500 into 1.101 plus 0.10 whole power 5. 500 into 1.10 whole power 5. So it's going to be how much? Let's see.
1.61051.
Just a second. Okay, let's multiply with 500. So you'll get 805.255. Okay, that's the answer. Let's go for the next one. See, if it is non-annual compounding, so the compoundings can be compounding frequencies. So you can see in some question it is annual, like annual compounding. Then comes the semi-annual compounding. Then comes the quarterly compounding. Then comes the week, monthly compounding, weekly compounding, daily compounding. Then can be hourly compounding, minutely compounding, secondly compounding. It can go to whatever extent. Okay. So these are all the examples of non-annual compounding. For you, much more important would be 1, 2, 3, 4, like almost till weekly. Okay. So now what would be the difference with this kind of compoundings? Let's say we are investing $100 for a span of 5 years at the rate of 10%. So the principal is $100, time is 5 years, rate is 10%, and like let's say you want to it's semi-annual compounding. What is that? Semi-annual
Semi-annual.
compounding. Yeah. So in this case, what you have to do, the formula changes to this. So P into 1 plus R by M whole power M into N. What's the meaning of this? If just let's say it's annual compounding, P into 1 plus 0.10 whole power 5 would be the answer. Correct? It's for 5 years. Am I right?
Yes, sir.
Since it is semi-annual compounding, the compounding is happening how many times, Hamsika? 5 times or 10 times?
So then it will happen 10 times.
10 times, of course. See, if I take 1 year, there are 2 compounding periods. So for 5 years, it will be 10 compounding periods. Since the compounding period is like twice, in the sense in a year, there are 2 times compounding is happening. So you have to take like 6 monthly interest. So in 6 months, it will be 5%. Am I right? Hello.
Yes, sir.
So we will take 0.10 divided by 2 whole power 10. Okay. So what I am doing here is M is the compounding frequency. Since the compounding frequency is semi-annually, 2 times compounding would be happening. So if you are earning 10% at the end of the year, in the middle of the year or half of the year, you will be earning 5% of it. Correct? So by m. M is compounding frequency. I did by 2. And then compounding frequency, that is 2, into number of years is 5, 10. So that makes sense, correct? If it is quarterly compounding, it will be r by 4 whole power 4 into 5, like that. If it is monthly compounding, r by 12 whole power 12 into 5, it goes in that way. Okay. So okay, will you note this one? Then you have to do the second question. Hello.
Yes.
Okay, note this and tell me if done.
Yes, sir, done.
Yeah, 2 minutes. This question. Oh, okay, fine. Thank you. Please do this. Yeah, I'm waiting. See, let's do this. $1,000 invested at 6 monthly interest rate. What's the value of the investment after 1 year and how much interest is earned? So first we will see the value at the end of the year. So 1,000 into 1 plus 0.06 whole divided by 2, 6%, 6 monthly interest rate. So it is half year. Okay. 2 into 1. This is the compounding frequency. Are you understanding what I'm saying? This is the principal. 1 plus r divided by m, the compounding frequency, into the compounding frequency into number of years. Tell me what is the answer and we'll see the answer we'll write here. And then we'll see how much interest we have earned. So 1,000 into 1 plus 0.03 whole divided by 2. So 1.03 into 1.03 into 1,000, it is 1060.9. So 1060.9 minus 1,000 will give us the interest. We have earned 60.9. Okay, shall we move forward? Let's check the answer for activity 2. it was annual compounding or non-annual compounding? Hello? It was
So
non-annual.
non-annual. They asked for 6 months.
Yeah, but like, acha, it was 6% for 6 months. Okay, 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 fine, fine, fine. Okay, I didn't see that point. Okay, okay, 2 minutes. It was not the yearly rate. Okay, this is 1,000 is invested at 6%, 6 monthly interest rate. So per annum it is 12%. It is 12% per annum, and it is 6 months. It is 6% for 6 months. So no need to change your compounding frequency. Just keep it like that. It will be like six. It will be whole square. See, did you understand the difference? It is 6 months for. It is like, I'll tell you what it is. 1,000 is invested at 6%, 6 monthly interest rate. That means 6% for 6 months, 12% for 12 months, 1% for 1 month. It is in that way. So since it is semi-annual, 6% for 6 months, it will be 12% for the entire year. Okay. So I have taken square and I did not divide this. Why? Because it was 6 monthly rate. Now you calculate what is the answer, you tell me. You should be very cautious while doing the questions. In fact, I even did not check this, see this point clearly. 1 plus 0.06, 1.06 into 1.06. 1 plus 1.06 into 1.06. It's like 1.1236 into 100. 112.36. It's like 1,000, na? 1,000. 1123.6. 123.6 is your answer. Okay, come on, do this fast. We'll move forward. Shall we move forward? Hello. Okay.
Yes, sir.
Okay, now comes effective annual rate of interest. So what is effective annual rate of interest if there are multiple compoundings happening in a year? Okay. So when multiple compoundings happen in the year, the compoundings can happen for less than a year period. That is for 6 months, for 2 months, for 1 month, for quarter, like 3 months, that is quarter, daily. Okay. Then what happens? The interest, in the sense, the rate of interest. See, if I tell you that I want to invest in some particular bonds, I want to buy some bonds, the rate what they are offering to me, or the interest what they are giving me, is 10%. Okay, and they are giving me interests. They are paying me interest which is compounded annually. But if I tell you it is compounded semi-annually, then I'll tell you this 10% would be something else. It will be 10.2, let's say. As the number of, just a second. Hello, yeah. So the point what I'm saying is, if it is annually compounded, the rate would be 10%. If it is semi-annually compounded, the rate would be 10.2. If it is quarterly compounded, the rate will be 10.3. If it is monthly compounded, the rate can be 10.4. If it is weekly compounded, the rate can be 10.48. If it is daily compounded, the rate can be 10.50. So what I mean to say is, as the compounding frequency would increase, your rate would also will not be exactly 10% which you are getting annually, but it will increase. But one thing you should observe is this all 10.2, 10.3, 10.4, 10.50 are almost very near to 10. They are very almost near to 10. Okay, they are very much almost near to 10. They will not be very much there. You cannot expect a very big deviation between this and the rate and the rates which I have mentioned here. Now, point number 2. Now you'll ask me a question, sir, why are these rates changing? See, let's say if you're getting interest, if let's say you're investing $100 in my company, and I promise you to give you 10% interest semi-annually. So what will happen is, in first 6 months, interest will be credited to your account, because I told you not 10% semi-annually. I'm paying you 10%, but not annually, semi-annually. Okay, so let's say the interest amount. See, this is 10% is not 6 months rate. This is yearly rate, annual rate. So of this, if I pay you interest semi-annually, I will be paying you $5. This is annual rate, okay, not 6 months rate. So 105 you will be having in your account. Now what will happen is, in the next 6 months, you will not keep these funds idle. Let's say whatever the excess $5 you got in your account, if you reinvest this at same rate, will you get higher interest or not? Will you not get interest for this $5 in next 6 months? Please tell me yes or no. That means whatever interest you earned in the first 6 months, you are again reinvesting it. Hello, are you understanding what I'm saying? Hello.
Yes, sir.
Yeah, just a second, just a second. See, this $5 what you're going to earn in first 6 months, you're going to reinvest this again. So when you reinvest this, you are going to get the interest on your principal as well as on your interest. So that is going to increase your rate. Let's say if the compounding is in quarterly. So like $10 is the interest I just offered you for the annum, or for like annually I want to pay you 10% on your principal. So every quarter I'll pay you 2.5, 2.5, 2.5, 2.5. Are you understanding what I'm saying? Hello? Hello?
Yes, sir.
I promised to pay you 10% on $100, that is $10, but I'll pay you that quarterly. So $2.5 if I paid you in first quarter, you will reinvest. Again, again this will reinvest. Again, this will reinvest. So on this, you'll be getting interest for next like 9 months. On this, you'll be getting interest for second quarter, 6 months. On this, you'll be getting interest for 3 months. On this you'll not be getting. So you're getting interest on these amounts for next months. So that will again increase the rate. That means what you'll be earning at the end of the year will not be exactly equal to 10%, but that will be around 10.30. That means you'll be earning 30 cents extra because of reinvesting it again, because the compounding frequencies are more. Okay, so there comes the concept of effective annual rate that will tell you exactly how much you have earned at the end of the year. So write on the formula. The formula for effective annual rate is this: 1 plus r is equal to 1 plus r whole power n, where r is the effective annual rate they'll give you, and small r is the period rate. That is the period rate they will give in the question. N is the number of periods in a year. So if I have to tell you the exact formula for effective annual rate, I'll write it here. Okay, you can follow that formula also. The same formula which I gave you, now the compounding frequency, that same formula they will give you here. Effective annual rate formula. R is equal to 1 plus R by N whole power N minus 1. Write down. Write in the formula effective annual rate.
Capital R or?
No, this is small r only. See, different textbooks have different kind of approach. Some textbooks they will give r is equal to 1 plus I by n whole power n minus 1. So they'll say I is the rate. So it depends, like it doesn't matter. Some formulas are 1 plus I whole divided by n whole power n minus 1. This formula also they are using effective annual rate. Every formula will give you the same answer. Did you understand the concept of effective annual rate? Hello?
Yes, sir.
Hello?
Yes, sir.
Yeah. So more compounding frequencies, more rate you'll get, more rate of interest, more return. So $300 initial investment. This is the amount, principal. This is the principal actually. 2% monthly interest rate. So 2% they are giving you for 1 month. Okay, so for you can convert this per annum wise also. If so, it will be 2% is for 2% is for monthly rate. So per annum it will be 24%. Correct or wrong? Yes. Hello.
Hello, yes, sir.
Yeah, of course. So shall we do a question?
Yes, sir.
Yeah. So if I want to write down this formula in words, I would write down this formula in this way. Effective annual rate is equal to 1 plus nominal interest rate by number of compounding periods whole power number of compounding periods minus 1. Right on this, we do the question.
Okay, sir. Done.
Yeah, 2 minutes, 2 minutes. Done? Okay, then you solve this question. So we can do this. Here I have already explained you nominal interest rate divided by number of compounding periods, whole power number of compounding periods. But in our question, they have given 2% monthly interest rate. This is not nominal rate. This is not the rate for 1 year. Correct or wrong? This is the rate for 2 months. Isn't it so?
Yes. Sir.
So what we'll do is, what is the value of investment after 2 years? So we will take 300 into 1 plus 0.02 whole power 24. Finished. Why I am taking 0.02 whole power 24? If I want, I can do this in another method. I can take 300 into 1 plus 0.24 whole power 2 I can do. Why? Because 2% monthly rate is 24% per annum. Then I can take 2 years. But here, if I have to take, if it is monthly rate, okay, monthly rate, they have given me 2% monthly interest rate. So I will take 2% here, and that is monthly. Then I will take whole, instead of 1 year, I will take 12 months. But here there are 2 years, so 24 months. Correct? Yes or no? Hello?
Yes, sir.
So now you can calculate the answer, and then second one will do. Second one also I am putting here, you can solve. They are asking you effective annual rate of interest. That means if this is 2% monthly rate, so yearly rate will be 24%. That makes sense, common sense. But that here the compounding is monthly compounding or yearly compounding? Hello?
Monthly, sir.
Monthly compounding. So 24% will not be exactly the answer. The answer would be near to 20%, but not exactly 24%. So I'll do that. So what you can do is, we have the formula for nominal rate. So 1 plus R. What is R? R is 0.02. I'm not going to divide this by anything. Why? Because this is monthly rate, not yearly rate. Let me be very clear. Okay. And like I am doing it for annual, I'm doing it annually. See, effective annual rate is always per annum. It cannot be for 5 years, 10 years. The concept itself is annual rate. Okay. So if at all monthly rate is given to you 2%, how many months make 1 year? 12 months minus 1. Just calculate this one, you'll get the answer. Do this. See, this works out only if they have given you annual rate. I've already written here nominal interest rate by number of compounding periods. But here the rate is monthly rate, na?
Sir, 0.2682.
Sorry?
0.2682.
Into 100. 26.82%, that is. And here the answer?
So the first one, 482.53.
482.53, yes, that's correct. Okay. There's no point here, 482.53. Let's move forward. Nominal and effective rates of interest. Now let me tell you what is the nominal rate. See, nominal rate, a building society. See, nominal rate is nothing but per annum. Effective annual rate can be like if they give you more compounding frequencies. Then you have to take the nominal rate and divide by the compounding frequencies, whole power compounding frequencies. So nominal rate, a nominal rate of interest is an interest rate expressed as per annum. I already told you, correct? But effective rate of interest is annual percentage rate. That means like it's also called as compounded annual rate. Okay. So annual percentage rate is nothing but exact rate per annum, considering the taking into consideration the compounding frequencies. Here there's just annual compounding, okay, in case of nominal rate. Let's see the question. You can find out the difference as well. 2 minutes. A building society may offer investors 10% per annum interest payable half yearly. If the 10% is a nominal rate of interest, that is 10% is annual rate of interest. Like, you know, if it is 10% per annum, it is 5% every 6 months. Compounded, so that effective annual rate interest would be what? So if it is like they are saying something like this, I have the formula for effective annual rate. What's the formula? 1 plus nominal rate by compounding periods, whole power compounding period minus 1. So 1 plus nominal rate is 10 divided by compounding periods 6 months, that is 2 times in a year, whole power 2 minus 1. Am I getting the same answer? Please tell me. Yes. Yes or no? Hello.
Sir, is it compounding period minus 1? I mean, is it
No, no,
in
no,
the power
down.
or?
It is
Okay.
minus 1 is down. Whatever you get the answer here, minus 1. Hello.
Okay, sir. Okay.
Into 100 to convert that into percentage. Second one is they have given 12% per annum interest payable quarterly. So 1 plus 12 by, there are how many quarters in a year? 4 quarters, whole power 4 minus 1. Do this 2, you'll get these answers. And at the end, you have to multiply with 100 to convert into percentage. Fast. Done with this, we'll go for the next one.
Sir, 25500.
Yeah, the answers are in front of you only here.
Oh, okay, sir.
You can check the answers.
Yes, sir.
Shall we move forward? Yeah. So I'm giving this as homework to you. Please do this. You want to do this right now or you want to do as homework? Hello?
So homework.
Homework? Okay. Discounting has been explained yesterday. Present value, what is that? Has been explained yesterday. The present value and discounting concept is done. Do this question. Come on. Do this question. I'm waiting. Yeah, what's the answer? Hello. The formula for present value is future
So
value
I'm
by
getting 0.0099.
no, you do like this. Future value by 1 plus r whole power n. That means in after 5 years you are going to get 1610. So 1610 whole divided by 1 plus 0.10 whole power. Like what is the how many years they have given? 5 years. Yeah. Now just calculate and tell. Hello.
So 999.68.
Yeah, that's almost 1000. Okay. So you can do this one by, you can put it in this way, 1610 into 1 divided by 1.10 whole power 5. Now 1.10 whole power 5 value is
1.61051.
yeah, into 0.6209. That is 999.68. That is 1000. Okay, done. So if you want, now here I have written something. So this I'll write it neatly. 1610 into 1 by 1.10 whole power 5. This particular thing is called as discount factor. Okay, the formula for discount factor. It's nothing but 1 by 1 plus r whole power n. That's the formula for discount factor. So here for this I got the factor as 0.6209. This I multiplied with this, I got the answer. Same concept they are mentioning here. And this you can find out in the tables as well. Tables are given at the back side of your book. But before going to that, we'll solve this question. Come on, do this. I'm waiting.
So 3969.16.
Yeah, finished. Hello.
Yes, sir, 3969.16.
Yeah, we will see. 5,000 is the future value. You'll get after 3 years this much. Divide by, or we'll say like this. We'll write it like this: 5,000 into 1 by 1.08 whole power 3. So this will give you the factor. The factor would be 0.794. So 5,000 to 0.794 will give you 3970. Okay. Now, so can you like what? Which is worth most at present values, assuming an annual interest rate of 8%. So which is, you have to find out right now this answer. Which is worth most at present values, assuming an annual rate of interest of 8%. 1 year from now, 2 years from now, 3 years from now, 4 years from now. What are they saying? 1200 into 1 plus 0.08 whole power 1. 1400 into 1 plus 0.08 whole square. 1600 into 1 plus 0.08 whole cube. You are going to find, not me. And tell me what is the highest value. Okay, come on, do this fast. I'm waiting. Yeah.
Sir, the highest would be the last one, 1800.
You were saying something, Hansika. What are the answers you got?
Sir, the Highest is the last one, sir, 1800. I got 2448.88.
No, actually, just a second. I think I did some mistake. Okay. The mistake is they're not asking the future values, they're asking the present values. Oh my god, I'm extremely sorry, just a second. Just small correction. So the correction would be, which is the worth most at present values, assuming an annual rate of interest of 8%. 1200 in exactly 1 year from now. That means you are getting 1200 after 1 year. 1 plus 0.08 whole power. Again, double task for you. 1400 by 0.08 whole square. 1600 by 1 plus 0.08 whole cube. 1800 by 1 plus 0.08 whole power 4. Can you find out and tell me now? That means 1200 into 1 by, we go like this. Square. Sorry, if this question I convert that as future value, then you can do this. In future value, you have to compound. In present value, you have to discount. Okay. So don't worry, I'll write the answers here.
Sir,
Done
for
small
this
calculation.
one, sir, on dividing, I'm getting the highest to be D again, 1323.05.
Yeah. 1323. So this is the highest. Okay. Done. So please make a note of this. Afterwards, we can move on.
Done, sir.
Yeah. Tell me. Hello.
Yes, sir, done.
Okay. Next is annuity. So shall we take this tomorrow? Hello.
Yes, sir.
Because again, from here the concept is totally changing. It is annuity. Annuity means I have to give you a proper explanation, then then till perpetuity, and then there are methods we have to do. So tomorrow I'll see if permits. I'll try to finish this chapter because only 3 concepts are there and 4 methods. Okay, so we will see tomorrow. Whatever it is, try to close this. Okay, so that we can start the next chapter, variances. Next chapter is, yeah, standard costing. I'll start this standard costing chapter. But see, can I give you some video, introduction video for standard costing if you want? Hello.
Okay, sir.
Hello. So see, I'm giving you for you to understand that what is standard costing all about. Shall I give?
Yes, sir.
Hello. Okay, I'm sending right now. Just wait. Standard costing. So watch that. After this chapter, immediately we're going to do standard costing only. Okay, tomorrow also we'll see if I can come early or I can manage any time in the afternoon or evening. I'll see, try to take early. Okay, or else then evening same time I'll inform you. Okay, thank you. Go to the concepts today, do all the questions.
Yes, sir. Thank you, sir.
Thank you.